Hi everyone, my name is Jim Pfister. I'm an independent contractor for SNIA and I'm Director of Persistent Memory and Application Enabling for the Compute Memory and Storage Initiative. I'm here today to talk about computational storage. Computational storage is one of the CMSI initiatives. We certainly have a lot of work going on in terms of technology, and we've been building a specification, but that hasn't stopped companies from getting out there and getting ahead of the computational storage spec and starting to write to where that spec is going in order to be able to show off the value of computational storage to you. So what I'd like to do is I'd like to show you an example demo of one of the companies that is doing a computational storage product. First, let me give you a little information about CMSI. This is where compute, memory, and storage come together. We do a variety of technical work, architecture, application, and programming specifications for computational storage, persistent memory, solid-state connectors and form factors, as well as solid-state drives and persistent memory drives. We also have a variety of joint alliance activities that we do with different marketing and standards bodies. We do outreach and evangelization. We have over 2,500 pieces of content in the SNIA educational library. This involves webcasts, white papers, courses, gives you lots of opportunity to learn more about persistent memory and computational storage. And we have a variety of videos, over 750 on the SNIA Video YouTube channel. What I'd like to show you today is a demo of computational storage. Computational storage is any architecture that provides services coupled to storage that offload the host processor or reduce data movement. So here's an example of one of our member companies that is doing a computational storage demo. All of the demos that you will see are proof of computational storage concepts. These are CMSI member companies that they're here to advance the specification. And so the following is a concept demo.
All right, so for our demo today, we're going to actually show how we're running the Azure IoT Edge on a computational storage device. So first thing we're going to do is we're going to create an IoT hub device. And you can see we're generating that here. Once that's created, we actually have to do some slight modifications in this instance for the Edge agent and hub. So what we're going to do is go in and actually change the runtime settings. And the reason we have to do this for our particular implementation is you can see there that current version is actually the Intel-based platform. And so we have to copy paste in the ARM beta version to be able to actually run the device in the ARM environment. So ARM is not fully released yet for Azure IoT Edge, so we're one of the beta testers for it. And now that we've got that updated, you can see we're able to go in and actually showcase that those particular devices are there. So now we need to do the final configuration at the device level. So we're going to go into our devices. You can see two screens here. The one on the right where we're typing now is the actual device itself. So root at node 1 is we're actually within the Linux subsystem of the storage device itself, putting that connection string in. The one on the left actually represents the host platform that the device is connected to. So we're now starting the IoT Edge platform. You can see that the Edge agent has popped up. We'll do a refresh again, and you'll see that we now have the agents and the host running. And all of this, again, is being done based on the storage device itself. So there's the hub and the agent. They're both running. We're using the Docker container application to do that. You can see there's the Linux instance being published. So now what we need to do is go in and refresh, and you can see the IoT server on Azure is now seeing these products as live solutions. We're next going to create a module here, and this particular one we're going to play with is an image analyzer. So we're going to utilize the capability of our system to actually run an image analysis application from the IoT hub on the individual device itself, in this case the computer vision application. So we're putting in all the variables that are required to allow us to use this computer vision device. And you can see we're updating all of those services and creating a container option for us so that this service will now be able to be run as you would in any other particular IoT platform. So doing all the wonderful modifications that are required, you can see we've got this now Azure IoT Edge device set up and ready to go. There's our image analyzer module. So again, it's not currently reported by the host device. So now we've got to go in and again update, and you now see the image analyzer is running again within the Linux server on the device itself. And the next step for us to do here is then now actually take advantage of having the device speak specifically to the IoT edge itself. So we're going to tell it to go ahead and run that particular tool. And you can see that it's looking for images. So basically what we've done is we've created a file on the Linux server within the device looking for pictures. So as a picture gets derived and allowed and stuck within the particular host device, you can see this is the Azure shell running on the website of the platform. Sorry, my mouse and I are having a little bit of a fun fight. But what we're doing is this Azure device is now live. So now we're going to run that on the actual Azure side. And now we've got both event monitors running. So for this particular one, I'm going to grab a picture of the Leaning Tower of Pisa. We want to see what that picture looks like. So we're going to grab the address for that image. We don't even need the physical image. We're going to now go to our host platform on the actual server device side, and we're going to store that image into the actual application device on the right. So on the left, we're physically copying an image from the web into the storage device that's shown on the right. And you can see where it says it just found that picture. It's gone out, grabbed the computer vision application, and has found and determined that we're now looking at the Leaning Tower of Pisa. So the storage device received an image stored by a host CPU sitting perfectly idle, and yet we were able to determine and use a computer vision algorithm from the IoT Edge on the actual storage device. So we're going to do it again. We're going to grab another picture. We're going to have some fun, and this time we're going to go from Italy to France, and we're going to grab a picture of the Eiffel Tower. So again, repeat the same process. We're going to take that image. We're going to actually physically store it on the storage device. So all the host platform is doing, similar to the example I mentioned, is storing the data onto the physical device.
Yeah, it's just a regular storage device, right? Regular SSD.
So it's storing it on the computational storage device, which is shown on the right-hand side. So we're looking at an output on the right of the storage device's Linux, but he's storing that picture on that storage device. So not only is it computing on it, but it's actually receiving inbound data from the host to process. Found the picture, and there we go. We are now seeing that it's gone out, and we have an Eiffel Tower.
That was a fantastic demo. If you want to learn more or if you want to participate more, I would encourage you to work with SNIA. SNIA has a variety of activities in computational storage. We have our technical working group with over 45 participating companies. They are defining what computational storage is and what the products can be. We have a computational storage architecture and program model that is defining the recommended behavior for hardware and software that support computational storage. That's in process today, and we would really appreciate your technical input on that. We also have a special interest group, the Computational Storage SIG. That provides education and benefits, use models, and other implementations of computational storage. It provides outreach via webcasts, videos, and event presentations. If you want to get involved, you can download the model. You can comment at snia.org/feedback. You can geek out at computational storage at the Geek Out via snia.org. And you're certainly welcome to join SNIA, join the CMSI, and join either the technical working group and or the special interest group. Thanks for watching today. We appreciate your time, and have a great day.